Okay, so we're going to try this one more time. I'm not going to go through the notes because by now you should have probably already written down the notes. If not, you can try and just pause it and write them down, or there is a notes. There's just this guy I uploaded. I sent you the link yesterday, and it's also in your CST folder. So for those of you, mainly periods 4 and 5, so first thing, carbon is very special. Carbon can form very, very many substances and structures. And the reason is because carbon, he swings both ways. Notice carbon can lose 4 electrons or he can gain 4 electrons. And because of that, he's able to bond very easily. Notice he can bond 4 ways here, or he can have a triple bond with nitrogen and a single bond with hydrogen here. He's very versatile. Now, this information here, this is basically stuff from biology. Molecules in your body are made up of subunits, very basic subunits, such as this phosphate and the sugar. And basically, the questions on the CST are going to be very similar to biology, DNA, protein, carbohydrate type questions. Always keeping in mind, though, carbon and these repeating units. That's kind of the overreaching theme. Moving down below, we've got 3 types of particles, alpha, beta, and gamma. Now, this has to do with nuclear chemistry. And most nuclear chemistry does not deal with the idea of fusion. Now, fusion is when 2 become 1. Nuclear chemistry is all about fission. And fission is when you have one thing that breaks up into 2 separate things. And that creates a ton of energy. An example of this is the hydrogen bomb. All the hydrogen bomb really is they're taking an atom of hydrogen, 1 proton, 1 electron, and they are splitting that nucleus, creating lots of energy. And that is when you have one thing and you're breaking it up into other things. Now, there are 3 main types of nuclear radiation, and most commonly known as radioactive decay. They are alpha, beta, and gamma. And the strength increases as the alphabet increases. So alpha, not very strong, beta, stronger, gamma, very strong. Now, the first thing I'm going to go over is how to protect yourself. So, if you had a sheet of paper, okay, that could protect you from an alpha particle. All you'd have to do is hold up a little piece of paper and you would be protected. Now, beta particles, higher in the alphabet, they're stronger. You would have to use aluminum foil in order to protect yourself from beta particles. Gamma particles, or gamma radiation, those are very high energy. They're very close to X-rays. So, nuclear power plants, when those break down and release energy, this is kind of what they're releasing. And in order to protect yourself, you would have to use something like a lead bib, like when you go and get an X-ray. They put a lead bib on you to protect you from those rays. Or a thick concrete wall. Okay, you need something very substantial to protect you from gamma radiation. Now, that's the first thing you need to know, is just knowing alpha, beta, gamma. The strength is increasing. You need something more substantial to protect yourself. The second thing I want you to notice is these equations. First of all, notice alpha particles. Alpha, ha, ha, in the HA, right? Alpha. Ha, ha, he, he. They're helium particles. So notice in these equations, 238 on top, 234 plus 4 does equal 238. Okay, they always have to equal. The bottoms, 2 plus 90 equals 92. You go over here to this equation, 238 on top equals 238 on this side, 92 on bottom, negative 1 plus 93 equals 92. So they're going to be the same. Now, because periods 4 and 5 missed out on the questions, I'm just going to go over a few of these just very, very quickly. The first thing, this question says, basically, why do the protons stay together in the nucleus rather than fly apart? Now, keeping in mind that you have all of these positives inside the nucleus, and you'd think that they're going to want to be apart from each other because they're the same charge. Now, the reason the nucleus does not fly apart is because of something called the nuclear force. Okay, the nuclear force is what holds atoms together. So it's the reason why the nucleus just doesn't fly apart. Number 22, what we just went over, which one of these is alpha decay? Alpha, ha ha, he, it's a helium atom. A does not have a helium atom, that doesn't work. Okay, B, 84 plus 4 is 88. 88 does not equal 90, so it can't be B. So we're left with C and D. Helium, we're good. Now helium is definitely 4,2Hg. It's not 0,2He, so the correct answer is C for that one. And the last example for these, a 2 centimeters thick piece of cardboard, which would be most effective against alpha radiation. Okay, most effective against alpha. It would block some beta, but it wouldn't be very effective against them. Now, switching over, need to change. Okay, so a couple of things. Number 33, which substance is made up of monomers joined together in long chains? That'd be a protein. And last one, these are those carbon ones. For the polymer, what is the repeating subunit? Notice you keep seeing this subunit over and over and over and over and over again. Okay, so that's the repeating subunit. This is the last one we're going to do. Which element is capable of forming stable chains, double, triple, and single bonds? That is definitely carbon. Carbon's special like that. Okay, so I hope that gives you an idea of what type of questions you're going to see, and I'll see you guys tomorrow. Make sure you come to Chemistry Cafe.